welcome you to this lecture series in marine hydrodynamics. Today in the last class we have talked about the basic equation as well as the associated boundary conditions related to wave motion, and we have seen that the free surface which is represented by y is equal to eta, and then we have the velocity potential phi, that there is a relation between them, and there are two such relations which relate them. One is the dynamic boundary condition, the other is the kinematic boundary condition. And now we have seen that the governing equation is Laplace equation, and it is the free surface which is responsible for the generation of waves at the water surface particularly. And we have considered the case of uniform depth of water, and we have seen that once we know the velocity potential phi by solving the governing equation Laplace equation along with the free surface boundary condition and the bottom boundary condition, then we can easily find out what is the surface elevation, that is eta. So, once phi is known, the velocity potential is known, we can always find what exactly is eta. So, with this background, today let us see how because we have seen there are two things associated. There are two terms here. One is the phase velocity, that is the rate at which the wave propagate, and the other one is the particle velocity, that is q bar, which has component u and v. So, today let us see how the particle motion takes place, because there is here we have a transfer of energy, but there is also water particle which also moves and they are also in motion. So, how the motion of the water particle, what kind of path they follow, and how the waves are generated, which path the wave energy propagation takes place. To understand this, let us have a look at again the wave motion problem. So, this let us suppose we have seen that when we have eta is equal to a cos k x minus omega t, in the last class I have found out phi, corresponding phi will be a g by omega cos hyperbolic k into h plus pi by cos hyperbolic k h into sin k x minus omega t. And here I always relate it, that this is my free surface, mean free surface, this is my bottom bed, and bottom bed is, this is my y is equal to minus h, and this is y is equal to 0. Then my free surface, I always say that this is y is equal to eta x t is my free surface. I have del square phi is 0, here phi y is 0, and we have on the free surface, here on the free surface we have phi t t plus g phi y is 0, that is exactly on y is equal to 0, and we have seen that I have a relation eta t is a phi y and phi t plus g eta is equal to 0. These two conditions are satisfied on y is equal to 0. So, basically then we have seen that if we have a given eta, then we can find what is the corresponding phi. Once we know phi, here I always mean del square phi, capital Phi. So, what I want to say that suppose once I know phi, what will be my u? U is phi x, and u is phi x. Once phi x is that, then what will happen? This will give me a g by omega, then k cos k x minus omega t, this is into, I have this term cos hyperbolic k into h plus pi by k. Similarly, we have v, velocity component of the y direction, that will be phi y, and this will be again a g by omega into k, sorry, phi y into k, this is sin hyperbolic k into h plus y by cos hyperbolic kh into sin kx minus omega t. Then we all know if xi and eta is any point in the fluid domain is the position of a particular position of the water particle at time t, at time t, then we have u is nothing but d is dj by dt, that is same as u is equal to ag by k, ag by omega into k. This is cos hyperbolic k into h plus y by cos hyperbolic k h into cos kx minus omega t. Similarly, we have d eta by dt, that is my v, and that will be again ag k by omega. This is sin hyperbolic k into h plus y divided by cos hyperbolic kh into sin kx minus omega t. Now what I will do, if I integrate this, so which implies this will give me my xi will be, I have to integrate with respect to t, and that will be ag k by omega into cos hyperbolic k into h plus y by cos hyperbolic k h. This is by omega. By omega, this is, so cos means this is sin kx minus omega t divided by omega. This is equal to by omega, and then we have eta is equal to, this is minus sign will come, minus will come here, so it is by omega. So similarly, eta will be ag k by omega, ag k by omega, this is sin hyperbolic k into h plus y by cos hyperbolic k h into, this is sin means this becomes cos kx minus omega t, and then divided by minus omega. And once, then what will happen? Then what will happen if I consider this as this term by omega square, I take it, this I call it, this also I call it, this term I will take minus omega square, I will take it. So then if this term I call it as ay, and this term I call this as my by, then my xi is xi by ay square, xi square by a square y plus eta square by, okay, there will be a constant term that I call it as xi naught, plus it will be a constant term associated with eta naught. These are integration constants which depend on the original time t0. So then in that process what I will have, then xi minus xi naught divided by ay square equal to plus eta minus eta naught divided by by square, and this is equal to 1. We have used the relation z since sin square kx minus omega t plus cos square kx minus omega t equal to 1. If you use this, from here we will get, and now what will happen, that means the particle, these are the position of the particle, xi naught and eta naught are the fixed point at time t is equal to, if it is they are the fixed position of the particle at time t is equal to t naught, then at any time t the particle will follow, and this a y b y, since a y is b y in general different, then we can always say that the particle will, the water particles will follow an elliptic path, with major and minor axis a y and b y. In fact, both a and y, they are all dependent on the water depth position dependent, and then again we can see that we can easily see that when y h tends to infinity, the moment h tends to infinity, then what will happen? Then we have sin hyperbolic k into h plus by cos hyperbolic k h will be e to the power k y and then similarly then we have, which is same as cos hyperbolic k into h plus y by cos hyperbolic h. And then since what will happen, because of this can be easily obtained. So, as a result we have a y becomes b y when h tends to infinity, and in the process when a y becomes b y, that means because, so that means my a y is equal to b y equal to, what will happen, a g k by omega square, a g k by omega square into e to the k y, and we also know that a g k by omega square is g k in case of deep water. So, omega square is g k, so that becomes a e to the power k y. So, minus infinity is less than y is less than 0. So, a y becomes this, and that means the particle motion will be, so I can call this as, hence in this case when a y become b y, that means initially the particles were following circular elliptic path, it was depending on, this was initially the particle motion was they are following a elliptic path for finite water depth, and it was decreasing as the water depth was going on. This was the a y part, this was my b y part, and this was decreasing as we are going down. On the other hand, when this is elliptic path for h is finite, on the other hand when h is becoming infinite, then they follow a circular path. So, here it becomes circular path. and here h is turning to infinity, the depth is infinite water depth. And here the radius of the circle is always a is the amplitude of the wave, because we have started with the wave, eta is equal to a cos k x minus omega t. So, this a is the amplitude of the wave, and once it is, this radius of this is decaying exponentially, because y is in the negative direction, it is y is always negative. So, it is decreasing exponentially, it is decreasing as you go down in the water. So, at the particle motion becomes 0 at seabed. This is the seabed. So, in both the cases the particle motion is 0 and there is no fluid motion that is possible at the bottom due to the generation of the waves at the surface. And here it is the follow a circular path, whereas in this case the follow a elliptic path, and here this is the radius that is always depend on the position of the particle. So, in the process what happen here, the surface concentration wave. So, in free surface gravity wave concentration is more on the free surface, is more on the surface, and particle excitation also is more on the surface, because this excitation is more on the surface, which goes down. As you go down, it comes to a stagnation, it comes to, there is no excitation of the particle. So, there is no wave motion at the seabed. This is one aspect. Another aspect is that they follow all closed elliptic path, and here they follow circular path here, because there is only wave motion. Although I will not go into the details, but I make a point. Is there question comes whether can they follow open path? Will they, suppose whether they always complete the path, or they still they can, before they complete the path, whether what happens to that. So, here actually what is happening here, the water particle, there is a, if I will not go to the details, but I just mention here that here in this case only energy transfer takes place, only energy transfer takes place. So, each particle excites the nearby particle, and that is the way the energy get transferred. On the other hand, if the situation in which particularly they will not complete a closed path, that means in that case before it completes a closed path, the particle moves to another point, and that is the what happens in case of a flood wave, in case of a flood, where the mass transportation takes place. Because in this case the particle, before it comes to the same point, this same particle, instead of being excited, it has already shifted to another point, and then the complete circle, closed circle is not formed, and in that case, and that is only possible when there is a transportation of mass. So, in energy transfer, particularly in case of waves in the ocean in general, where there we have the situation of wave propagation only, there is no transfer of mass. On the other hand, when there is a transfer of mass from one point to another, in such a situation the particle will change before the complete cycle is formed, the particle changes its position, and in the process particle changes its mean position. So, in the process no closed path is formed, and that is the basic difference between basically the wave motion in a sea, without mass transportation and with wave motion with mass transfer. So, that is one of the very important, this is one of the very important point to note. So, with this now I will look into another aspect, that what happen, how the we have seen that stationary waves. Let us relate the stationary wave pattern in case of when a wave propagates near a wall. Stationary wave pattern. Near a wall. This is another interesting point to be noted. Now, we have seen that if I just say eta is equal to a cos k x minus omega t, these are very simple examples, but the observations are very important. Eta is equal to a cos k x minus omega t. Then we all know that the corresponding velocity potential will be a g by omega cos hyperbolic k into h plus y by cos hyperbolic k h into sin k x minus omega t. So, then what will happen if I just say that I have another wave where eta is a combination of two such waves, eta 1 plus eta 2, where eta 1 is a cos k x minus omega t plus eta 2 is a cos k x plus omega t, and the resultant here it will be 2a cos k x cos omega t, and the corresponding velocity potential phi will be phi 1 plus phi 2. Phi 1 is the velocity potential associated with theta 1 and phi 2 is the velocity potential associated with theta 2. So, if I do this, then what will happen here? Then I will have a g by omega 2 a g by omega cos hyperbolic k into h plus y by k h. This is sin k x minus omega t, and the other case it will come across cos k x minus omega t, the other one will come out sin k x eta t phi t plus theta. So, here okay, cos k x cos omega t, and this will give us sin will give me cos k x sin k x sin omega t, sin k x sin k x cos omega t. Okay, I hope this is clear, because if we have, let us have a look at it. We have phi t plus g eta is equal to 0, just to have a check. Phi t plus g eta is 0 and y is equal to 0. If this is 0, that is my phi t is and y is equal to 0. This is y is equal to 0, this term will be 1, phi t will give me minus, it is minus omega into sin omega t phi t plus g eta. Now, this will be again, this will be, it will not be sin, it will be again, this is cos phi t plus g eta. So, this will remain as cos k x, this will be sin omega, this will be into cos k x sin omega t. Let me have a look at this, minus omega, this will be minus sin. If I take minus omega, phi t is minus this is plus omega. Okay, I have a minus sin minus omega, then we have 2 a g by omega, and this is 1 cos k x sin omega t becomes cos omega t, and then omega cancel, 2 a g by omega plus g times 2 a cos kx cos omega t, that is 0. So, this is the right answer. So, that I will let us put it in a proper way, minus 2 Hg by omega into cos hyperbolic k into h plus y divided by cos hyperbolic k h into cos k x sin omega t. And here what is happening? Let us look at this one. What will happen to, because this is a standing wave, the corresponding wave is a standing wave. We have, as we know, when the two waves collide, two progressive waves collide, they will form the standing wave like this. Now, question comes, if I have a near a wall, if I have a vertical wall, then near a wall I have phi x will be 0, and if phi x is 0, suppose this is the position of the wall, phi x, suppose the wall is located at the position x is equal to a. So, at x is equal to a, phi x is 0, that will give me that, because my phi x will be, in this case I have phi x, my phi x will be minus 2 Hg by omega, then I have a k, which is cos hyperbolic k into h plus y by cos hyperbolic k h into sin k x into sin omega t, and then this phi x is 0 at x is equal to a. If phi x is 0 at x is equal to a, implies sin k is 0, and when sin k is 0, this is nothing but sin n pi, that means k is equal to, or a is equal to n pi by 2, n pi by k, and k is nothing but 2 pi by lambda, n pi by k is 2 pi by lambda, and that is nothing but pi get cancelled, n by 2 into lambda. So, this is my a. And what happened when a is n by 2 into lambda, that is, then what will happen to my eta there? Eta at, so 2a cos k is 2 pi by lambda into n by 2 into lambda. This is this becomes lambda, this becomes cos 2a cos n pi. So, basically this is becoming 2a cos n pi, and for all n is equal to 1 to 1 once. So, the maximum, so what will happen to eta? So, at a we have seen at x is equal to a, so eta will be maximum. Because for all n it can be maximum of value of eta. So, if eta is maximum in a standing wave, maximum of eta, amplitude eta becomes, amplitude will be maximum here, maximum amplitude will occur only at the nodal points, antinode point. So, that means the point x is equal to a has to be antinode point. So, like this, if so, what we are concluding from here, that obviously it can also be seen that that here the horizontal velocity is 0 near the wall as far the fluid particle is concerned, and in the formation of standing waves we have seen that eta attains the maximum, eta will be the maximum, the amplitude becomes the maximum. So, what it says that if I have a, suppose I have a wave which is propagating, if I say, suppose I have, or I will put it this way, even if I say I have a wave which is a, suppose the initial wave which was propagating in this way, I say I have a wall in any direction you go, suppose I say eta 1 is equal to a cos k x minus omega t, this was the wave which was approaching in the positive direction, and eta 2 it hits a wall, particularly a vertical wall, and that will be, once it hits the wall, the wave will be back a cos k x plus omega t, because it is a vertical wall, the whole wave will be back, reflected back, and then the resultant wave will be eta 1 plus eta 2, which is nothing but 2a cos k x minus omega t. So, what is happening here? So, that means the formation when a progressive wave is propagating hit at a wall, then the wave will be returned, particularly it will be reflected back, because the amplitudes of both the waves are same, only direction is opposite. So, it will form a standing wave whose amplitude is twice that of the individual waves. At the same time, what happened near the wall, because there is a standing wave formation has taken place. So, what is happening near the wall? In this standing wave formation near the wall, the antinodes are formed. The antinodes are formed near the wall, and that is one of the very interesting observation which has been clearly derived. Now, what happens? Suppose with this understanding of formation of antinodes, I will just look at the oscillation of a. Let us illustrate this by example, how it helps us in understanding problems of ocean engineering. I will take a very typical example. Consider a one dimensional bay. So, when I think of a one dimensional bay, I just look at, suppose I have a suppose this is x is equal to L, this point is x is equal to 0. This is a one dimensional bay where this is the mouth and this is the head of the bay. This is the bay mouth. Then now, if I just say that a wave initially it was propagating in from here, so my eta will be a cos k x minus omega t, because it is propagating from this side, it will be, and this eta 2 will be a cos k x plus minus omega t. Once it will hit the wall bay head, then it will back. This is my second wave, this is my first wave. So, the resultant will be 2a cos k x minus omega t, and then what will happen? What will happen to my, sorry, this is cos k x into cos omega t. So, what will happen to my eta 0? If I look at what happened to near the bay head, my eta 0 by eta L. If eta 0 by eta L, eta 0 is the amplitude of the wave near the mouth, whereas eta L is the amplitude of the wave near the head. So, eta 0 by eta L modulus will be, because this is 2a cos k 0 cos omega t by 2a cos k L cos omega t, and that gives me, if I look at the modulus, that will give me 1 by cos k L, and that 1 by cos k L, what will happen to this? So, now what will happen if cos k L will be 0? If cos k L is 0, that means this will be cos 2n plus 1 into pi by 2. So, if this will be 0 at these points, and then that will give me k L is equal to 2n plus 1 into pi by 2, and k is 2 pi by lambda into L is so, which implies Cn can be 1 0 1 2 or any integer value, real natural number. So, that pi get cancelled. So, which implies my L is equal to 2n plus 1 into lambda by, this is lambda by 2. So, what it says, L is there is a 2 here. So, this will be 4, sorry, there is a 2 here, it will come as 4. So, 2n plus 1 into lambda by 4. So, that means when L is equal to, this is a very important relation, when L is equal to 2n plus 1 into lambda by 4, my eta 0 by eta L will tend to, so this will tend to what? This will tend to infinity as L becomes 2n plus 1 into lambda by 4. And then what does it mean? So, this becomes very large, that means, and my this was my bay, this is my eta L, this was my eta 0, this is my x is equal to 0 point, this is x is equal to L. So, this distance, if there is a wave which was propagating, and then what will happen in this, x is equal to 0 to x is equal to, in fact x is equal to L, x is equal to 0. So, the distance is lambda by 4, and here it is the bay head, there is vertical wall. So, there will be standing waves will be formed there. So, that means this distance is 1/4 of lambda for when n is equal to 0. This is 1/4 of lambda, because there is a, so near the bay head there is a standing wave will be generated, a standing wave will be generated, and it will be generated near the wall, and here this distance of total wave, and then again here, because this distance is lambda by 4. So, at this point for the eta 0 by eta L has to, if it has to be infinity, then this has to be nodal point, and as usual antinodes will be found, antinodes will be found here. So, that means when a wave propagates, it is a case of a one dimensional bay. So, when a wave propagates from the deep sea to the bay area, so there is a chance that when L is equal to 2n plus 1 into lambda by 4, if the bay is a vertical one and this distance is L, then there will be a condition of the water particle resonance, it will resonate, oscillation will take place, and that resonance condition of the bay oscillation will take place, and amplitude becomes extremely large, becomes large. Once the amplitude, that means the bay resonance will take place. In that situation, we always say bay oscillation has taken place. And amplitude becomes large. So, this is one of the very important point. Now, with this I will highlight few more things. So, the second thing I want to tell here is that what happened to the higher modes of oscillation. So, we have seen when n is equal to 0, we have L is equal to lambda by 4, and then we have seen that the total only 1/4 of a wave which has taken place in this point is x is 0, this is x equal to L. Now, when n is equal to 1, then what will happen to L? L is equal to 3 lambda by 4. In that case, suppose I say L, this is 0, x is equal to L, this is x is equal to 0, and then because this point resonance, this will be a nodal point, this will be anti-nodal point. So, what will happen? This distance is 3 lambda by 4. So, this much will be happen, and if I take n is equal to 2, then L is equal to 5 lambda by 4, and in that case if I look at it, this is x is equal to L, this is x is equal to 0. So, then what is happening? The lambda is going on decreasing with very increase in values of n. So, in fact, these are called, if we go on increasing n, then we will see that smaller and smaller waves will be formed, and that means the wavelength lambda of the higher modes of oscillation will go on decreasing. Initially it is 1/4, L is lambda by 4, then L is becomes L is fixed. So, as we go on increasing, n goes on increasing, the length of the wave particle goes on decreasing, the individual modes. So, these are called modes of higher modes of oscillation, or basically n is rather call it modes of oscillation. And in fact, in this case when n is equal to 0, we call it fundamental primary mode of oscillation, then n is equal to 1 called secondary mode, n is equal to 3, this is called tertiary mode, and so on. So, this is higher modes of oscillation. Now, I will just take another typical example. In this case, suppose I think of a shallow water waves. Let us consider the case of a shallow water waves. If we consider the case of a shallow water waves, then what happens? I have already seen, in case of shallow water, we have already seen C is equal to lambda by T, and for shallow water C is root G H. So, if what will happen to lambda? So, then if C is lambda by, then T will be lambda by root G H, and lambda becomes, our lambda is, because so T is lambda by root G H. Let me just do a little homework further. So, T is lambda by G H, and we have seen L is equal to 2n plus 1 into lambda by 4. So, that means my lambda is 4L by 2n plus 1. So, when I say T is equal to lambda by root G H, and this becomes 4L by 2n plus 1 into root G H. So, this is, so I call this, for each n I have a Tn. So, I call this as a Tn, because for each values of T corresponding to n refer to this as, and this also I call it as lambda n. So, Tn, so that means my period of oscillation Tn becomes 4L by 2n plus 1. into root gh, that is in case of a bay. So, this is the period of oscillation in case of a bay and in case of shallow water. That means, when n is equal to 0, my fundamental mode of period of oscillation, that is called the primary mode, as period associated with the primary mode is 4L by root gh, and then that is T0, my T1 will be 4L by 3 into root gh. And another point here to observe, not only that, the period of oscillation T n varies as 1 by root h. So, when the water depth is increasing, the depth is increasing, h is increasing, T n is decreasing. Higher the water depth, lower the period of oscillation. So, basically that is another observation, that is what we have made. And again, the period of oscillation, this L is anyway fixed. So, this will be T1 will depend on the water depth, and that will be, because for a particular bay the length is fixed. So, once the bay oscillation, when S tending to 0, that means when the water depth is reducing, the period of oscillation is going on increasing. So, in fact, this is a situation which is often observed in case of a bay, even if in the shallow water, under the assumption of shallow water region. Here we have seen that how it is happening. Now, with this background, we will go to see that what happened in case of a basin. In case of a basin, again I will consider the same case. Let us take a basin which is of, the basin is of length L. Suppose let us say this is 0, this is A, the length of the basin is A, and we have, if I again call it my eta, because standing waves will be formed. So, if I say eta is equal to 2A cos kx cos omega t, then what will happen to my, because at the two ends del eta by del x will be maximum, because also it can be seen that del eta by del x will be 0 at x is equal to 0 and x is equal to 0 and A, because here the amplitude will be maximum and amplitude will be maximum, then del eta by del x will be 0 at the two ends, because antinodes will be formed in the both sides. We have a vertical wall, so antinodes will be formed. So, in this case, this is basically I am talking of a basin oscillation. Basin oscillation. So, if this is the case, that is that will what will happen here. So, once del eta by del x 0 at x is equal to A, that will give me this. If I look at the substitute for it, del eta by del x is equal to 2A k sin k x into cos omega t, and one sin k x, this is 0 at x is equal to 0, this is automatically satisfied. On the other hand, if sin k x is 0 at x is equal to A, which implies sin k is 0, and that is given sin n pi, and which implies k is 2 pi by lambda into A is equal to n pi, pi get cancelled. So, implies my A, rather I will put it lambda will be 2A by n, 2A by n will be lambda. A by n. Okay. So, that means I call this, refer to this as corresponding lambda as lambda n. Then if I look at this, then what will be my C is root gh, C is lambda by t, and this is 2A by root gh, and once this is root gh, lambda is 2a by n. If I put lambda is lambda n as 2a by n into root gh, this becomes Tn. So, in this case what we are observing? That again in this case I have seen that Tn is 2a by n into root gh. So, when n is increasing, n is tending to infinity, Tn is tending to 0, and further here also we have seen Tn also varies as 1 by root h. So, again smaller the water depth, and here I am considering the case of shallow water also as an example. So, here also we have seen that the higher the modes of oscillation, smaller the period will decrease when the mode of oscillation increases. So, in both the cases the first few modes of oscillation will be very important, places modes of oscillation. Are significant. And when this situation happen, that means when I have lambda n is becomes 2a by n, that means I have a situation of harbor oscillation, closed basin oscillation, or I say harbor oscillation. In fact, this harbor oscillation and bay oscillation or a basin oscillation, because harbor is also I call it a rectangular harbor, and it can be told as a basin, it can be called as a lake. So, this lake oscillation or a basin oscillation takes place under this condition, and in both the cases we have seen, both in case of a bay or a basin oscillation, we have seen that the first few modes of oscillation plays a dominant role, and whereas the higher modes of oscillation does not contribute much to the oscillation of the harbor, because impact will be very less, wavelength will be smaller and smaller. So, in the process one always look into these higher modes of oscillation, particularly the not higher mode of oscillation, rather the first few modes of oscillation, and that is why in the when you think of a tank or any basin, you always look into the first fundamental mode of oscillation or secondary and tertiary mode of oscillation, and that becomes a very important aspect. In fact, in all wave resonance problems, and it plays a very significant role in the harbor oscillation. We have in fact, it has been observed that this during a storm or during a high wave situation, the damage in a harbor or port is not much, rather it is very high when the port after the storm subsidized, because when the fundamental frequency of oscillation of the harbor matches with the forced frequency of oscillation, then harbor oscillation takes place, and during such period the damage becomes more because of this bay oscillation or the harbor oscillation which takes place, and that is a what is in all design one has to take into account this distance. So, if one knows a particular nature of a wave at a particular bay or a basin, so one always has to, any new design or even if design of various structures, one has to take this into account, so that harbor oscillation is avoided or the bay oscillation is avoided if possible in while designing or developing any infrastructure near a bay or a basin. With this today I will stop. Thank you.